Okay, so let's start. Good afternoon, everybody. Uh, I'm going to be making this presentation on shaping the future with Java. And in this talk, I'm going to explain a little bit about the history of Java, about the Java ecosystem, and some of the more recent releases of Java and some of the important features that were implemented for those releases, and also a little bit of a peek into what features are in the pipeline for future releases. I hope the break was refreshing for you all. How many of you have programmed in Java or code in Java actively right now? Okay, that's pretty much 90%. How many have programmed in the last 5 years other than Java? Okay, quite a lot. So you are polyglots, all of you. So my name is Muralidhar Rao. I head the Java platform group in Bangalore. I work for Oracle. And before I proceed, I need to tell you that you can't make any business decisions based on what I'm going to tell you about the future of Java. So you need to look at the associated documentation for the release before you make such decisions. At any time, if you have a question, please raise your hand and you can interrupt me. So Java is a pretty large ecosystem, as you can make out from some of the numbers here, right? It's of course the #1 programming language. There is a survey that happens every year, and we've been maintaining the #1 position for quite some time. The number of active Java developers runs into the millions. And of course, the number of instances of the Java VM runs into the billions, right? And the cloud itself accounts for 20 billion plus Java instances. So it is a pretty huge, what should I say, user base and also a community. And it is expected because Java, as you know, is over 20 years old. It started in 95, 96 time frame. And it has grown very popular and big over this period of time. So how does it happen? How does one decide what should go into the next release? So there is a lot of collaboration. There is quite a big community which provides continuous feedback. There is opportunity for contributors to also contribute ideas, contribute implementations, and so on, as we'll be seeing a little later in the presentation. So we have a Java magazine, which is quite a large subscription base. We have a community of Java user groups. Typically, there is a jug. They are called jugs, and they are, in most of the important cities, there is a jug that is quite active. And Java champions, many of the speakers that you heard today, they are Java champions. And so that's an independent, what should we say, activity by the jugs and other Java champions. So it is not regulated by Oracle. And of course, the biggest contributions are coming to what people contribute to the OpenJDK. As you know, Sun Microsystems open sourced this in 2006, 2007 timeframe, and so OpenJDK is completely in the open now, and I'll be discussing some more about how much more open it is now. So what are the key themes or directions in which Java is evolving, right? It is of course based on the computing environments that are available today and keep Java relevant to those environments, right? So it is of course open. It was open quite some time back, but it's not now going to get even more open, as I'll be discussing. It is continuously evolving. As a language system, it keeps introducing newer ideas. All language systems borrow from each other. right? So some particular paradigms or some particular even syntax and styles of programming keep getting borrowed across language systems. So Java is no exception. Java, when it started, came from C++. As you know, the syntax is almost very, very close to C++, right? So there is a lot of give and take between languages as they evolve, and Java continues to evolve as more and more new applications and new frameworks evolve. So Java needs to adopt some of those ideas so that those newer applications can be implemented very efficiently in Java. Of course, it has to be nimble. That means the change should happen rapidly enough that the developer community sees that as a evolving language and thinks that they can apply the changes and the new features that are coming into Java. They can exploit it quickly in the new age applications that they are building. And of course, scalability is a big area. We have to make it as scalable as possible, whether it is multiple cores, whether it is different types of memories, and of course the cloud, with different types of containers and so on. It is the #1 runtime in the cloud. Okay, so if you see AWS and Google App Engine, it is Java is the #1 runtime, right? That means applications run on the Java platform. And it is the #3 on Azure. Did I hear a question? No. The Java runtime is the foundation of the cloud IaaS, PaaS, and SaaS. A lot of these applications are built on the Java runtime. Does anybody know what is the Java runtime? What do we mean by the word runtime? Anybody wants to take a guess? Yes. So the VM is a critical component of the Java runtime, right? It is the engine on which Java applications run. So when you compile a Java program, it generates bytecode, and then bytecode is what you execute on a JVM. So a virtual machine basically emulates the Java bytecodes, correct? So in addition to the interpreter and compiler engine, JVM, the other important part of the runtime is the API. The entire set of the core foundation libraries that Java comes with. All that is part of the runtime. Okay, it's available to you, and the Java specification covers the language as well as the API. Right? Unlike other languages like C and C++, they focus only on the language. All the other libraries like they are not part of the language standard, right? They become standard by virtue of it being used. It's not really a published standard as such. With Java, the specification of the APIs of the libraries, they are also standardized. Okay. The other big commitment that Java made very, very early on in its journey was to maintain backwards compatibility. Okay, so it is makes a huge demand on such a platform. Some people might have the impression Java is not changing fast enough, but Java has made a commitment to its millions of users that if they write a Java application, it's guaranteed to run in future versions, and we take great care to ensure that we don't break anything. So that's that's something that that makes us, what should we say, very, very cautious about implementing new things there. Obviously, it's very difficult to roll it back. We can't just introduce something and pull it back in the next version. So we would only install it after there is enough confidence that yes, it is a necessary feature, and it is already tried and tested in quite of the other language systems perhaps, or even in the research community, and there is a thumbs up on implementing that in Java. So that's the time it gets into Java, so it's somewhat behind, but that is intended. Okay, that's the way it is designed to be. So what are the investments we are making in in the OpenJDK platform? So security is, of course, number one priority. It has been so since the beginning. As you know, the JVM runs in some kind of a sandboxed environment, and there are various policies and ways in which you can determine, what the application that runs on the JVM can access. Whether it can access the file system, whether it can access the network, and then so on and so forth. So right from the beginning, it has been a priority and continues to be so. Because in today's cloud environment, it is even more important that we have the same kind of a sandboxed environment in your containers. A container is kind of a shell around your application and the runtime, that keeps it from impacting any other containers that are running on the same machine. So there's a lot of isolation, and it's a world by itself. So so obviously it needs to take care of security quite well. Of course, Java developers is also a focus. We just need to keep adding features and enhancing the Java platform so that it improves their productivity, right? How quickly you can build. So one of the big themes of the Java language is to let the system or the underlying system do all the heavy lifting, right? And the application programmer is supposed to focus more on the application logic. So which is the one thing that comes to your mind when it comes to what is handled by the Java system as opposed to an earlier programming system like C or C++? Garbage collection, that's right. So you do no longer keep track of what memory you're allocating and when you got to free it, right? And whether you're freeing it correctly or not. You can't free the same memory block twice. That would be disaster. If you don't free it, that's also disaster because you will very soon run out of memory. Why is garbage collection even more important today? Or why is it so critical for enterprise applications? Because maximum memory is consumed? Yeah, I mean, enterprise applications, of course, their memory footprint is large. They handle lots of, concurrent transactions. So obviously, there are many users that are connecting, and it will consume more memory. But what else? Avoiding deadlocks. Yeah, I mean, that's a system. Yeah, so if your locking synchronization is incorrect or less than efficient, it's going to show in less throughput or it'll have higher latency. But what is the other most important reason for it? Yeah, I see a hand. Yeah. Yeah, that is true. It is similar to the answer this gentleman here in the front gave. So yes, it is an enterprise application. It's like a server side, and obviously it gets a lot of traffic, and so it consumes a lot of memory than an application that's running on a desktop would, right? But the other most important thing is, yeah. So yeah, so one one way could be if you're consuming more memory than required, then you're being unfair to somebody else who is running on that box. But where I was trying to get at was these are all 24/7 applications. They're always running. They're always on. Okay? Just imagine that you're leaking some amount of memory every second. How long does it take for you to just hit the wall and run out of memory? With a server-side application, it's going to happen in a few hours or a few days or a few weeks. Because of the nature of enterprise applications, they're always on. They never stop until there is a fatal crash or something, right? So garbage collection and its accuracy and its, what should we say, its operation, its cycles that it keeps doing to continually free memory so that the demands for allocation, new memory never fail. Okay, so it's a very important aspect of the system, and it's one of the things that keeps your enterprise applications running. People, applications run for months without having to be restarted, right? There are a few more features that are going to show up in some of the future releases. One is increasing density, which is called Valhalla. So many of these projects are described under OpenJDK. So if you go to openjdk.java.net, you can see what are called JEPs, the JDK enhancement proposals, and they're all identified by a JEP number. And if you go to that website and just give JEPs / whatever the number is, you'll find the description of that project. So you can find what is Valhalla. Yeah, you had a question. Yeah. Oh, if GC is so important, why is it a low priority thread? Is the question. Any clues? Yeah, one is if you have memory, there is no need to run the GC because you can always allocate from whatever is available, right? But the question is still valid. Why won't you be running it all the time? Why do you, why is it a low priority?
Because you want to keep connecting the resources when it is not having the resources, that time only you want to run. And now the just 1 minute. Yeah. And now that garbage collection algorithm in like Z1, H1, now it has got much, it can run parallel or coherent way, then it can use more efficiently.
Yeah, I mean, so one way of triggering a garbage collection is to wait until you have run out of memory, right? You try to do an allocation, there is no more memory available. Now you start doing a GC, which will free the memory, and then you will be able to satisfy the alloc. That's one way of doing it. But today, garbage collectors don't wait until that almost end point. They employ heuristics, right? And they say, how much am I allocating? What is the rate at which I'm allocating newer objects? And so they have some kind of a high water marking, and they can trigger a GC, once it is 80% consumed the available memory, and things like that. So so there are different types of GC algorithms, and they can employ these heuristics. However, the real reason for why GC is a low priority is GC consumes resources, right? When the GC runs, there are stop the world GCs, right? Where when the GC runs, the application threads have to be stopped. And so GC is sucking away time from your users, right? It's going to reduce their response time. It is going to lessen your transactions per second, and so on and so forth. So it has an impact on the throughput and latency of the applications. And that is the main reason that you don't want to overrun the GC, right? If you keep the GC running all the time and it is doing a lot of these GC activity, it's going to drop your application throughput. So that's the main reason. Okay. Improving startup time. So there is AOT. I don't know how many of you were in this the talk earlier before lunch by Christian Tallinger. He spoke about the JIT compiler, and he also mentioned about the ahead of time compiler. So the AOT is one project. AppCDS is application class data sharing. We will go into some of that in the coming slides. Improving predictability. So GC is an area of active research. People are continually trying to improve the GC in terms of speed of execution, how long the GC takes, and how effective it is in mopping up memory. Right? So it's an area of research, and there's always some, at least 1 or 2 new GC algorithms that people are working on. So ZGC and Shenandoah are 2 such projects in OpenJDK that are currently running. And the last one is about monitoring and profiling, right? So when something goes wrong with the JVM, when it crashes, or even if it has not crashed, it is running, but now the response has come down. So if you want to know what exactly is happening, you need to obviously monitor it to detect that something is going wrong. And then you need to be able to profile and see some of the statistics even in a running JVM. And so that's where the Java Mission Control and Java Flight Recorder, these two tools are invaluable in trying to find out what's causing the observed behavior in the JVM instance. Okay, so we said it is becoming more open. So, what exactly do we mean by more open and it's moving faster? If you know the history of Java, the major releases used to happen once in 2 to 3 years, approximately. Okay, so Java 5, Java 6, it was called 1.5, 1.6, and so on. This naming, nomenclature keeps changing from time to time. So then Java 6, 7, 8, 9, 10. We are right now, the latest release is 10. But all the releases before Java 9, right? So between 9 and 8, there would have been like almost a 3-year, period of time. And then similar between 8 and 7 and so on. So major releases happened, once in 2 to 3 years. And there were lots of minor releases, which essentially fixed a lot of the problems or bug fixes, plus some minor enhancements and things like that, which did not change the spec, right? Every Java major release has got an associated Java specification. And so things that, did not break that spec, but, needed to have some small enhancements and fixes, all that went as minor updates. And of course, we had critical patches, which are called the CPUs, which are essentially all your security vulnerabilities. So they get fixed, and that happens on a quarterly calendar. So every 3 months, we have a CPU update that fixes at least all the security vulnerabilities. So that's been the thing until 9. Java 10, which released in March, just last month, is the first 6-monthly release. And so that's what is the thing about making Java faster. So one of the disadvantages of having a 2 to 3 year release time between major versions was all the features that were planned for that major release are available at just one shot, right, when that major release is made. But if you take Java 9, for example, it had over 100 features, okay, or 100 JEPs. And of those, maybe about 5 or 6 were the really big ones, right? For example, Jigsaw, the Java module system, was a sort of a key feature release for Java 9. And unless that key features, are already implemented and tested and found to be, good enough to go, the release will not be made, right? They will hold back a release until those key features are in there. So those are called feature-based releases. But now we are moving into a time-based release. So the disadvantage with feature-based releases is that there were lots of smaller features, that got implemented, let's say, in the first few months of that 2 to 3 year time window. They never reach the hands of your customers or your users, right? They had to wait until it made it along with all the other features in the major release. So there is a lot of skew in there are small features, there are medium features, there are big features, but everything got bundled into one major release. So we are trying to correct that with this 6-monthly release or faster cadence. And we are going to go on a time-based release plan. So whatever features are available and ready to go at that time, they make it. So it's like a train leaving the station. If you're there on time, you make it. Otherwise, it's the next opportunity is just 6 months away anyway, even if you miss the release. So we feel that's a lot more efficient. And also, we live in an agile world today, and a lot of changes is happening quite fast. So even from that point of view, making a release every 2 to 3 years seemed, not right. So what does the new release model look like? Okay, so if you see JDK 6, 7, and 8, they have the timelines when that's going to become end of life. JDK 7, is sometime in 2020, 22. JDK 8 goes up to, 25, 26, in between that, right? So those are the 6 6, 7, and 8 are the old release cadence. In the new, we are going to have 9, 10, 11. You see there. Of course, there are after 11, there is up to 17. There are another 5 or 6 releases in between. They all happen every 6 months. But once in 3 years, we have what is called a long-term release. That's LTS stands for long-term release. So there are other popular operating systems that also go using this model. And these two focus on 2 different types of adopters. Right? So one are people who are either individual developers or startups or small teams that want to keep up with the latest. So even if you throw a new version every 6 months, they are willing to consume that, use it for developing their applications and libraries and whatever, right? But if you take large corporations like a healthcare provider or a bank or and so on, they want more stability, right? You can't keep telling them every 6 months, okay, go deploy this new thing, because they are subject to a lot of certifications stuff, and they have to do a lot of testing, all those recertifications based on the new stack they are using, and that takes a lot of time. So usually, they tend to have much bigger, 8 years, 10 years. They continue to use the old stack, so they do not upgrade as frequently. So the LTS, the long-term support version, is geared for enterprise customers, whereas the 6 monthly releases are geared towards individual developers and fast-moving platforms. Okay, so what it means is after 10 becomes available, there is no further support for 9. Okay, so if you are using Java 9 and 10 became available, now you need to move to 10, because all the updates, the security updates, patches, etc., will no longer be applied to 9. That's kind of end of life. It's over. Okay, so so this is one of the choices that Java users will have to make going forward. Which one do you want to use? You want to use the 6 monthly release, or you want to use the LTS? Okay. Yeah. 8 is not LTS. 8 is kind of a special, because it's like the transition between the old cadence and the new cadence. So 8 has got kind of a much longer life cycle, and it's available until for the next 5, 6 years or more. But the ones after 8, 9 and 10, they are all 6 monthly cadences with limited support. After the 11, which is going to come out in September this year, is going to be a long-term version, long-term support. Okay, so the releases are made in March and September, 6 months apart. So the one that happened in March was 10. The one that's going to happen in September will be 11. And 11 will be maintained for, at least 5 years. You'll keep getting public updates. Yeah. Well, by support, so the question was, what exactly do I mean by support is available versus not available? And when we say support, we mean like customer support. There are people who sign up for a support contract, and usually enterprises do have support contracts with almost all the vendors of the software that they those applications that they use. Because in production, when something runs into a problem, you want experts to fix it very, very quickly, and so that's the reason for the support. So such people, customers who have signed a support contract will of course get, based on the severity of the problem, there are SLAs, and depending on the problem, they'll get a fix within a few days, within a few weeks, and so on. Sometimes if the problem is so critical that the production thing is completely stopped, then there can be a separate, what is called a BPR, a separate release that's made for that customer. But these are for paying customers. If you use OpenJDK, which is in the open, then there is no question of, if you run into a problem, what do I do? You got to do it on your own. You got to figure it out, or wait for the next release. Okay. Did I answer your question? Okay. Well, that's because of the, the versioning thing which has undergone a little change. It was year.month. The 24.9 is yy.m. Whereas the 23, 29, these are all simply just running serial numbers. So after Java 8, the next release is 9, the next release is 10, 11, so it just keeps on increasing. We wanted a yy.m kind of a scheme, but that was for some of our presentations had that, but we are now going with just a simple number. Yeah. No, when I say support for Java 9, see when the Java 9 is announced, after that it will get 2 updates. Remember I mentioned about the quarterly updates? So those are the security patches, and so that will be available in the first quarter after initial release and then the second quarter after initial release. But beyond that, it will not be patched anymore. So after 6 months, end of life happens for those releases. No. Java 9 are all those people who are, who don't mind moving, fast enough. There are lots of people who are willing to keep pace. Just because we have, enterprise customers, we don't want to ignore that part of the user community. Yeah. And, it's not like Java is unique. Almost everything, operating systems, Ubuntu, for example, and, all kinds of Linuxes, they all follow something similar, right? So you have a version that comes out very, very quick. So if you want the latest features and you want to improve on performance and all that and get the biggest bang for those improvements, move on to the latest platform as quickly as possible. But the stable versions will the ones that are for longer time usually will appear a little later. Yeah. Mm-hmm. Yeah. Yeah. So the question was, do I have to wait for a long-term support release? And if I'm interested in exploring some of the features that are available in 9. See, once the feature is introduced, it's going to continue, right? So what's available in 9 will be available in 10, 11, and so on and so forth. So even if you are interested in 11, you can. There's nothing that stops you from using features of Java 9 and and refactoring part of your application. Mm-hmm. Well, but I see there's dev, there is testing, there is production, and lots of things are baked and cooked for a while before it lands up into production. So you can start earlier. After all, it's how many months are we talking of? It's 6 months to the. Yeah, September will be the first long-term release that we are going to make in this new cadence. Okay, Jigsaw was the real major revamp that happened in Java 9, and essentially Java platform itself, all the libraries under the Java platform also got modularized. So it's a module system, and there is syntax associated with what a module uses, what it requires for it to function, what it exports to other users of that module, and so on. So this is how the Java library itself, all the packages in the Java platform, get reorganized as different modules. Now there's a big advantage to using a module system because it allows us to now reduce the footprint. Okay, earlier it was monolithic. If you remember rt.jar, does anybody know rt.jar? So all the, I don't know, 20,000 plus classes in the Java, library API, everything resides there, right? And even if you were to use only like, I don't know, let's say 1,000 of them, you would still have to use, that same rt.jar. But with a module system and an associated tool called JLink, okay, allows you to, strip down the JRE to only those essential modules that it is actually making use of. So a full-blown JRE might be, I don't know, 150 MB, but if you put it through a JLink and let's say you have a simple application, the JRE for that, if you use JLink, it can be, as small as maybe 10 MB, right? So it makes a big difference, especially in the cloud, where you want to pack, as many instances as possible on a box, and obviously consuming lesser footprint is going to give you big advantage in that environment. So a lot of good advantages of the module system. Yes, yes. What you see here is really the dependency graph. Okay, so if you take the top right corner java.sc.ee, that module depends on all the arrows that are coming out of that, right, and so on. So this is exactly the dependency graph. So if I'm not using java sc.ee, for example, it's not a Java EE example application, then I don't really need to use all of that. Java.corba and java.transaction and java.xml, all that is not required. And let's say I'm just using java.se. So only whatever it uses is needs to be packaged in the JRE. Yes, it will be in the bin folder. So if you download the JDK, you'll find it along with Java C and JConsole and all the other things. Yeah. This is literally the laundry list of all the features that got implemented in Java 9. So this is what it looks like if you wait for a major release. Okay, it is some 100 plus. I don't expect you to read this. You can, you can go to the website and figure out what this is. There's no need to even take the photograph. But so now you get the the impact of, let us say if you have some of those things which are really small were available in the first month itself. They all waited for 3 years until the Jigsaw was ready. Right? So that's the disadvantage of major releases. And this is just to drive home that point. What are these? Containers. So in the world of containers, we want to definitely be very much more secure, right? There is a lot of sprawl because, pay as you go, and, scalability, can lead to a promiscuity of resource usage. So you'll keep, spinning up new threads, spinning up new instances, using more memory, and so on and so forth. But, there's a sprawl, lots of instances. There is a lot of mix of different applications. All this is the environment of, a box running applications in containers. Heterogeneous machines, right? A data center consists of heterogeneous machines. JVM basically came into the world because of that, right? Write once and run anywhere. So there are a whole bunch of platforms on which Java will run. You don't have to modify your code for that or rebuild it. So these are all very critical even in the cloud world, where we are finding the same heterogeneity in hardware platforms. We have constraints on security on application not having an impact on other applications. There should be full isolation and things like that. And if you see Java, it kind of maps very well to what Java is already designed for. Okay, so it's a managed runtime, hardware and OS agnostic, of course only for the platforms that we support. So Oracle, OpenJDK releases for Windows, Linux, Mac OS, Solaris Spark. Okay, so on these platforms, it will, if you run an application, you can run on all these platforms. Of course, multiple, versions of those operating systems are supported. I think at any point of time, the latest plus the last 2 releases of that OS. So the matrix is quite big of, the heterogeneous type of platforms that Java supports. And compatibility is a key design goal. We never make changes that will break your applications. And so in a fast changing world, that's a very, very important, what should we say, thing to rely on. As an application developer, you don't want the rug to be pulled under your feet every now and then. Yeah, you want to guarantee that what you wrote 6 months back will run without any problem. And of course, there is a rich ecosystem of libraries and support for almost anything that you would want while building an application. The other major announcement that was made in the last Open World Java 1 conference, that all the commercial features. So so there are 2 major releases of Java. One is called the Open JDK, the other is called the Oracle JDK. Right? Open JDK is open source. It is distributed under GPL v2 with class path exception. But Oracle JDK is not open source, so it's under a different license. It's called the BCL, or binary code license. So Oracle JDK had certain features that were not found in the Open JDK. But that's only temporary, because with very soon we are going to have Oracle JDK and Open JDK matching as far as features are concerned. So the only differentiating factor between these 2 JDKs will be their support, the support lifetimes. Yeah. Also, Oracle will work with other Open JDK contributors to to make the infrastructure complete. So automated build system, automated testing system, automated verification or compliance testing. All this needs to be available to the Open JDK community so that they can also participate in coding new changes, building, testing, and then finally integrating it. Well, they have said it will happen very, very soon. And so these are some of the things that differentiates it right now. So you can see Java Mission Control, JMC, and its counterpart, Java Flight Recorder, which runs inside the JVM. Mission Control is like the client visualization library. So application class data sharing, Java usage tracker, and so on are so-called commercial features. And to unlock them, you have to use a special command line option that will allow you to use them. So it's available, but then according to the license terms, you need to enable it so that you can use those features. And of course, if you are using those features, you need to have the appropriate license to use them. Right? So coming back to the timeline, which was your question, we hope that it happens by 11, but don't quote me on this. It could happen by around that or a little later. So sooner than later, it's going to happen. No, it won't be a big bang. It all depends on how quickly these things are done. And remember, they are not all of the same size in terms of effort. So they could land in different releases. In Java? No. These are already as per the Java spec. Okay. So the spec is not different for Oracle JDK versus. Some of these tools are outside of the spec. Yeah, for example, a garbage collector. It doesn't tell you which garbage, the spec doesn't tell you this is the way garbage collection needs to be done. It just says you need to have a garbage collector whose job is this. Right? You could implement any number of newer garbage collectors. So things like that, okay? How much time do I have? Okay, let's quickly go to Java 10. So there are several places in which you can download the JDK. There is, of course, openjdk.java.net. There is java.com. There is of course what is called the Oracle Technology Network, OTN. So you can download it from there too. So this is a snapshot of the OTN page. So JDK 10 was made available March, just last month, just a few weeks ago actually. And this is the page that makes that announcement. And if you go down to the features, now you see a much smaller list, because Java 9 you saw that the whole slide was full of full of features. Here you have a much smaller set. You see those numbers to the left of the features are the JEP numbers. Okay, so each feature is captured under what is called a JDK enhancement proposal, and there is a web page corresponding to that. And if you want more details, you can always visit that page, openjdk.java.net/jeps/the number. Okay, so you can see now what are the features that got added in Java 10. It's just this small set. Okay. So let me throw some light on some of those features. JEP 286 is called Local Variable Type Inference, LVTI. And this is just I would say a shortcut or a developer productivity kind of feature where it lets you get away by typing less. Okay, so if you see the the two statements at the bottom of the slide, this is how you would do it without. Can you all read it? No? What can I do? Well, it's in the slide, so I can't. So let me read it out for you. Sorry. I think I skipped, yeah. So this one is a traditional declaration. You say array list of string, list equal to new array list of string. So you can see the duplication here. On the left you are saying, this is the type declaration of the variable called list, and then you are creating a new object of that type. So you are repeating it. So it's like double the typing. And same thing here in the next line. So how would you do it with LVTI? You would say var list equal to new array list of string. So it infers from this. This is the local variable type inference, saying the type of this variable list that you are declaring is this. Okay, so it's just a way of shortening the boilerplate code or the amount of this thing you need to type. There is still strong typing. Okay, it is still maintaining all the essential features of the Java language. It is not becoming any weakly typed or anything. It is just that it is saving you some typing.
Very first time when I saw this type of declaration, documentation, I was a little confused with this scripting languages like JavaScript and all.
Yes, so you're right. I think the gentleman here says he's observed this in some of the scripting languages. So scripting languages typically, in fact, forget about this. They don't even declare a type. Okay, you can use a variable as a string, and the very next line you can use it as an integer, and the third line you can use it as a float or whatever, right? So it is very, very minimal or minimalistic when it comes to declaring. So this is called dynamic typing. And a lot of your scripting, these things, they do that. But usually what you write in a scripting language is a few tens of lines or a few hundreds of lines. You don't write 50,000 lines of code in a scripting language like Perl, for example. Because if you made a mistake in the type, it will manifest as a problem at runtime, and you will spend sleepless nights in trying to debug that and finding the root cause of the problem, right? So strong typing is good for building big applications that run into tens of thousands of lines of code. This is invaluable. You cannot have like a dynamic typing system and then do your debugging quickly. Okay, so what you pay for, what you save at the time of coding, you will pay for many, many more multiples of that effort in debugging. So it is worth its weight in gold. So this wire, yes, you're right. Some of it, loosely typed or dynamically typed languages and scripting languages, they do use this kind of feature. So we are borrowing the syntax, but not necessarily the intent. It is still strongly typed. Okay, the where keyword says that the list, you need to infer its type based on what follows. Okay. Application class data sharing. So this is about loading, shared libraries. You know what I'm referring to? What's a DLL in Windows and what's a .so in the Unix world? Okay, so that's what this is, essentially. So you can have one copy, loaded in memory, in physical memory, and that same copy can be mapped to, multiple processes in their own virtual address spaces. So what do we save here? We save memory, right? So if you have 20 instances of Java running on a machine, but you have only one copy of the library. So that's what this is, class data sharing. This was available anyway for system classes. That's been extended now to application classes. I think this is even more relevant when you're talking of cloud infrastructure, where you would have multiple instances running on the same box. Then there is a JEP 319 that talks about root certificates. So when you install a Java, it already comes with a whole bunch of root certificates that you do not have to install. So if you're building a web application, it already has root certificates of, I don't know what those names are, but things like VeriSign, Thought-A, and all these you might have heard of. And so they are already in that, so you don't have to take extra effort to create the trust store and populate it with these certificates. They are already built in. So out of the box, it can work, and HTTPS will work. Okay. There is also ZGC, which is kind of a low latency garbage collector. As I told you, garbage collector is an area of intense research. So we have one more in the pipeline. Pause time should not exceed 10 milliseconds. You heard of, in the morning, you heard of this serverless and the function as a service, fin, bin, and all this stuff. It makes enormous impact. The startup time needs to be, if you have a function that executes for a few tens of milliseconds and goes away, you cannot have a JVM starting up and taking 2 minutes for starting up. Okay, so it needs to be also nimble, very light-footed, and come and go as quickly as possible. So lots of changes are happening in the background to sort of achieve that goal. Okay, there are also early access binaries, which means I think somebody here asked a question: should I start doing Java 9, even knowing that I want to do 11? The thing is, even today, 11 early access will be available. So you don't even have to wait until the actual release, for you to start building your application that is, let's say, designed to run on 11. So that's how all our partners actually work, right? Within like a few weeks or a month of the announcement of the availability of a new release of Java, big, Apache releases so many other, packages that depend on that, but very quickly. How does it happen? Because they start early and they use this. So they are continually revving their applications and refactoring them to use the new API and so on, so that, almost very quickly they can release their dependent applications. What is in Java 11? Yeah, it's a very small set of features. There is a dynamic class file constants. There is another low overhead garbage collector called epsilon. And there is something called remove EE and Corba. Because EE and Corba is kind of going away. It's not very popular. It's not heavily used. So those things are going away from the Java platform. Also, some of the modules like the XML processing and so on were more related to Java EE, and they are also available in the Java EE packages. So it's kind of a duplicate, and there was extra effort involved in keeping up with it and keeping it in sync. And there was also something called the standards override mechanism. Has anybody heard it or used it? Standards override mechanism. So there was a way for you to update the JDK. When I say JDK, I mean the JDK where you install it. It'll come with all this bin, lib, and these folders. And there is something called ext. So there are some standards which Java doesn't control. Namely, XML, for example. Security is another example. So these are governed by other standards bodies. And when a Java release is made, it can, of course, adhere to the latest version that was published at that point in time. But let's say a newer version of the XML or this thing was made available. It was not immediately available in the Java platform. So you could override what was installed with the later version of those libraries, like XML processing and crypto security and stuff. Okay, so that override mechanism is gone now. Okay, it's no longer supported, and which means anyway was we considered that to be a duplicate effort, and that's been removed. And there is a substitute thing called upgradable modules, which allows you for updating a module even after installation. And local variable syntax, what I told you about LVTI for local variables, extended to lambdas. If you know, Java 8 had two critical, major update features called lambdas and streams. So lambda is your functional programming, syntax to describe snippets of code in line. And it's available in so many other languages. It's been made available since Java 8. So the local variable, type inference is extended to those lambda, snippets of code. So these are the things available or slated to be available in 11. There are a few other things that we are working on. Optimizing data. So if you know, everything in Java is an object. It's an object-oriented language. And of course, there are primitives, which are non-objects. And you have to keep, if you have a primitive and you want to pass it as an object, then you have to box it, unbox it, and so on. If you are having an array of elements, an array of objects, every object there carries the overhead of the object header and so on and so forth. So unlike an array in C or C++, an array of int, for example, will have only integer. And it occupies much less space. Whereas if you have an array of integer object in Java, each element is going to have the overhead of the Java object header and so on and so forth. So it kind of makes it much bigger. Also, while accessing it, you do a double indirection. So you access it with a reference to the array, you extract the element, which is a reference to another, and so you got a double indirection. Okay, so for some of these reasons, C++ things are much faster, and we're trying to address that by by optimizing, data layouts, and these are only for what are called, data objects. These are like final classes. You cannot, extend them or subclass them. What else? And then that is that project Valhalla, value types. So there is an effort going on to see how we can, introduce newer syntax that allows you to have, more optimized data layouts. So these are some of the things in the pipeline. Improved Java native interoperability. This is what goes by the name of JNI, Java native interface. And it is used for, cross-language invocations. Okay, so the, Java platform itself depends on, lots of libraries which are native or written in a different language. For example, the Java graphics relies on OpenGL. OpenGL is implemented in C++. So how does Java make a call to OpenGL library of functions? So it has to use what is called a JNI. But the JNI, as it exists today, is pretty cumbersome. The way you have to create it, you have to declare an interface, you have to create, header files, and then, you have to write some proxy, code in C or C++ before you can make this marriage happen. Okay, it's pretty cumbersome. And there is an attempt now to make it much more simpler. And that's using the support of what is called a libFFI, a foreign function interface. Okay, it's nothing new. Foreign function interface was defined in Lisp in 1960s. So all of the concepts have been kind of evolving over 40, 50 years and keeps getting packaged and repackaged. Yeah. So some of these are running as projects under OpenJDK. If you go to openjdk.java.net projects, you will see a whole lot of projects that are defined out there. And there is work going on, okay, because it's a community process. Remember, it's not just Oracle employees of the Java Platform Group that are working on this. There are other companies, there are other individuals, there are other jugs, and so on, contributors who are working on that. So, they'll be working on it. At what point of time does it get targeted to a release or get integrated and merged with the release? Depends on its state of readiness. So when it gets ready, it'll get in. Yeah. Well, deprecated, you will know every time a Java release is made, there will be some items that are marked as deprecated. And the intent is that it can go away. It is going away for sure. But is it going away in the very next release? Not sure. It could go away in the next release. It could go away in the release following that. But it is an indication for developers to say, hey, this is going away, please refactor. So you will see even in the logs there will be alerts if you are using those APIs saying using deprecated API. So when we don't say when it is going away, we say it is going away. So better start working towards it. Who's talking? Can you raise your hand? Ah, there. Okay. Yes. Deprecated means that it's going away. Okay, how are you doing on time? I don't know. We started a little late, so yeah, maybe I should take a few questions. Yeah. Somebody else from here, from the back. I saw some. Yeah. You started a big debate. You will see, I don't know, terabytes of flaming wars on the internet about this. Java, is it a pure object-oriented language? It's not because of the fact that, I don't think there is a very easy answer to this. You should be talking to language designers and say, why do they use this particular word? Why do they call it this? Why do they have funny brace and this kind of structure? I don't know. Primitives are obviously much faster. They fit into registers. They fit into the smallest memory word size of the machine. And so dealing with that is obviously much faster. So if you want great speed, you want to operate on those. If you want the other, useful aspects of object-oriented programming, the ability to subclass and, do all these runtime typing and, that kind of, then you use classes for that. Okay, but that doesn't mean primitives do not have a role to play. Even today, there are critical pieces that are written in C, that are written in assembly, and so on, just in the interest of making the platform faster. So even Java has got some things that are written in assembly and maybe C and so on. Yeah. That's an interesting thing. His question is about JVM languages. Do you know what's a JVM language? Exactly. Scala is an example. So there are tons and tons. There are, I think, tons of languages. So Scala, Ruby, Python, Clojure, Go, I think, Kotlin. There are tons of them. I think there's a web page that gives you, just this last question. So what's a JVM language? The compiler for the JVM language, compiles the source code of that language, generates output as bytecode. A bytecode can run on the JVM. That's why it's called a JVM language. What is the advantage to those languages? They get the advantage of that language being available on all the platforms on which JVM runs without having to do anything. And if you use the foreign function interface, you can latch on, or you can make use of all the APIs, libraries that are available with the Java language. You can extend that without having to make those libraries again for the new language. Okay, I think I've run out of time now. If you guys want to discuss further with me, you can send me email. I work out of Prestige Technology Park, Mercury Building. Okay, thank you.